My fabulous chemistry minions, video number 5. Today's video is going to be on table G. Big bad table G in a reference table. There are 3 pages of notes for this video. I'm going to do 15, 16, and 17. Basically, this is how it's going to go. Page 15 is going to be the theory on all 3 games that we're going to play with this table, and then 2 pages of examples on how we are going to play games with this table. And then there's 1, 2, 3, 4 pages of practice and 2 reflections to do. So pay attention. Hopefully the video won't be too long. Here is your first learning target: saturated, unsaturated, supersaturated. That's one of the games. Then I'm going to find changes when the amount of solute in the solution, when the temperature or volume is changed. That's 2 separate games. When the volume is changed, it's a whole new game. So, and that's the one that's actually on the Regents exam the most. So let's get started. First page 15 is going to be me discussing the theories. So here's big bad table G. Notice it has solubility in 100 grams of water. So that's the key piece there, in 100 grams of water. It's a lawyer statement, because if I have more water, I can obviously get more stuff to dissolve. And then we learned earlier that as the temperature goes up for solids, more will dissolve. See what I'm saying? So we're just going to play some games. So first game is using our vocab words from before: saturated, supersaturated, unsaturated. So that's the first game we could play on something like this. So if the mass and temperature values fall on the curve, then it's going to be saturated. Let me show you what I mean. As an example, more definition first, right? Solution holding the maximum amount at that temperature. That's what saturated means. Now we'll get into the example. 40 grams of NaCl at 90 degrees. So the first thing I'm going to do is find NaCl on this chart, and it's that line. It doesn't match perfect my yellow line, but I'm trying to just cue you in on that line. Now I'm going to do 40 grams at 90 degrees. So highlight 40 grams, highlight 90 degrees. Where do they cross? Boom. Oh, look, that's on the line. On the curve, saturated. Got it? Okay, good. Below the curve. What happens if I'm below the curve? Below the curve, by definition, is unsaturated. We did this in a previous video. This is obviously now holding a solution holding less than it's supposed to be able to at this amount. In other words, if I added more, I could still get it to dissolve. Okay, like you didn't put enough sugar in that Kool-Aid yet, right? So here's an example. KNO3, 70 grams, 60 degrees. So I'm going to highlight KNO3. See how that works? You see KNO3 with that little line pointing over there. There's a lot of crisscrossies on this chart. So you got to just take your time, make sure you highlight in your mind the right line. Like, I don't want you to actually be highlighting these lines every time. You're going to use this chart a lot, and you're going to make a mess of your chart. If you really need to, there's plenty of reference tables. If you have to mark it up, mark it up. So now I'm going to find 70 grams, 60 degrees. So 70 grams, 60 degrees. Where they cross is that line, that dot. Notice that dot is below the curve. It's not on the curve. You'd have to go up quite a bit to like 106 grams, right? I'd have to raise that red dot up to 106 grams or change the temperature. It's below the line. That's what we're getting at. Next one is then above the line. So above the curve, by definition, is supersaturated, meaning it's holding more at that temperature than it should be able to. So let's do an example so you can see. NaNO3, 20 degrees, 110 grams. Find NaNO3. There he is. Then I'm going to intersect 110 grams and 20 degrees. Notice now I am above the line on the curve. So that is super saturated. How you guys feeling? Okay, first set is done. Okay, next part is one of multiple ways to do the same game. This is where we're just going to find 2 points and subtract. Okay, that's what this game really is. So find the mass that will dissolve minus the mass that's added, and that will equal the mass that doesn't dissolve. So I could have more powder that doesn't dissolve because I put in too much sugar into the water, or because I put in not enough and I could add more. So both games are just subtraction, guys. Find the 2 points, subtract. It's really that simple. So we're going to use table G, find the amount that will dissolve at both temperatures, subtract the two values. Whoops, let me go back, write that down. We're still on page 15, just going over. That's the 1 dot. Notice I got a 2 dot coming up next. So save room on that 2 dot. Ready? Here come the 2 dot. The mass dissolved at the higher temperature minus the mass dissolved at the lower temperature equals the mass that will precipitate out. Again, find the 2 points and subtract. That's it. That's really what this game is. So it really doesn't matter if it's how much will precipitate out, how much more can I add. Any of these games is just going to be find the 2 points and subtract. We'll do a bunch of examples. Okay. Again, this is the third game. Now, this is what happens if New York State decides to change the amount of water, and they do it a lot. They either say, yo, you have 200 grams of water. Well, if I have double the water, I should be able to dissolve twice the stuff. So find out how much will dissolve in 100 grams and double it. If it's 50 grams of water, well, that's half of 100. Find out how much will dissolve in 100 grams of water and then half it. It's that simple. So that's what this says. Manipulate that value based on the amount of water. So that is the third game. Whenever I've seen a Regents exam, I very rarely have seen them actually ask this question at 100 grams of water. They've usually changed the amount of water. That's usually the game they go to. So that's going to be the last in our examples on page 16 and 17. So which are solid and liquid. So this is, or solid and gas. This is the last piece of theory, right? Solids slope up because they increase in solubility as temperature rises. So something like that. Everybody that goes up from left to right is a solid. And the opposite is true for gases. They're going to slope down because as temperature goes up, their solubility goes down. That was in previous learning that we learned already, but this is how it comes into play. Now let's get through these examples. I know it's going to be a long video. Let's just make sure we got it so we can do all this practice. If you pay close attention, you should be able to handle all the practice. So first game, again, saturated, unsaturated, supersaturated, on the line, above the line, below the line kind of thing. In order, though, it's saturated is on the line, unsaturated below, supersaturated above. Super means above. So here's the line of interest. HCl, 60. You're going to highlight 60 grams and 47 degrees Celsius. So 60 grams, 47 degrees Celsius. Where those meet, look, that's on the line. So that's going to be saturated. I'm not writing the word saturated. You are. Hope you're listening, because your notes are going to be weird if they don't. So next example, 20 grams of KNO3. Let's highlight KNO3. Now we're going to crisscross 20 grams, 20 degrees. Where that crisscrosses, see how that is below. So below the line is unsaturated. Next example, moving along, trying to make this go faster. Highlight NaNO3 in my mind. Link up 70 grams and 10 degrees. Whoops, below the line. Below the line is unsaturated. So that the answers there were saturated, unsaturated, unsaturated. Okay. Next part is find the amount of solute added to 100 grams of water to make a saturated solution. So how much more do I have to go to get up to the line? So here's our example. At NaNO3, I need, about 106 grams of water to have a saturated solution. So straight up, I need 106 grams. That's the answer. KLO3 at 30 degrees, how much do I need to add to make it a saturated solution? Well, you know saturated solution is right on the line. So let's read it. I need to add 12 grams, right? To get it saturated. There's always going to be a plus or minus here, but you got to know that if it's on the line, it's exactly the the 10. And if it's not on the line, you have to make adjustments. You have to guess accurately, right? Because you're using the chart to figure out those numbers. 50 degrees, KNO3. So highlight KNO3, 50 degrees. Here we go. It's about 85, 86. That one's really close to 85. It's almost really right in the middle. Okay. So now the mass that does not dissolve, we're actually going to subtract. There's no subtraction in that one. These guys are going to be subtracting. So if 60 grams of KNO3 are added at 100 grams of water, again, lawyer statement, 100 grams of water just means read the chart like normal. At 20 degrees, how much did not dissolve? So that tells me 60 grams is going to be higher. This is not an unsaturated or a supersaturated solution because there's a bunch that didn't dissolve, right? So I'm going to say at 20 degrees, 35 grams should dissolve, but I added 60. So 60, I picked 34. So 60 minus 34 grams, 26 grams. I don't actually have to mark the 60 because that's how many I put in. It's only going to hold 34 at that temperature. That's how much it didn't dissolve. One more, 30 grams at 25 degrees of KLO3. Oh, that 3 should be definitely subscripted. Well, at that temperature of 25 degrees, it will only hold 10 grams. So 30 minus 10. 20 grams did not dissolve. So here we are subtracting. We're going to do some more here. The solute that precipitates after a change in solvent temperature. So we're going to find two temperatures up to the line, subtract the two. Okay. A saturated solution at 75 degrees is cooled down to 15 degrees. How much precipitated out? So go 75 degrees up to NH4Cl. That is, I'm going to guess probably pick 62. Then at 15 degrees up to the same line, I probably picked 37, maybe 38. Subtract those two numbers. Oh, I picked 36. Looking at that line, I probably should have picked 37. But again, there's going to be a plus or minus, so you'll be all right. Again, find the two spots and subtract. 50 degrees to 25 degrees. So at 50 degrees up to KNO3, probably picked 84 there. 25 degrees up, 41. Oh, I picked 84 to 41, 43 grams different. Okay. All right, on to page 17. Mass of solute that could be added after the change in solvent temperature. So here I'm going to heat it up, and how much more could I add? So again, find the two spots, subtract the two answers, and then that's these two problems, and then I'm going to get into changing the actual amount of water, which is big. So at 65, I can add about 55 that looks like to me. And then, I'm sorry, that's at 55. If I go up to 65, I can get 60 in. So 60 minus 55, 5 grams. If I heat it up, I could get 5 more grams of stuff to dissolve. Okay, KNO3 at 20 is heated up to 70. Well, that's a big jump in temperature. We should have a big jump of how much we can get to dissolve. So at 20 degrees, I can get 36, maybe 37 grams to dissolve. At 70, I can get a lot more. Oh, and it's hidden behind the 5. Sorry about that. I picked 132 minus 35. Ooh, and I even said like 36. So there's a little variation, right? 97 grams is the difference. So that was a whole bunch of different ways we could do 2 points, subtract. Now let's change the mass of water. This is the game the Regents exam is going to play with us. How many grams of KNO3 can be dissolved in 50 grams of water at 40 degrees? Well, that was not 40 degrees. Ouchies. That was a technical error on my part. There's 100 animations on this thing. So read 40 degrees up. It's actually going to be slightly lower. And KNO3, oh, slightly higher. But it's actually right about the right line here. The line going up was a little off, but it is 40 degrees. So I can get 65 grams to dissolve, but I only have half the water, so it's 65 grams divided by 2. Or I pick 64 grams divided by 2, 32 grams. Okay. Next one's going to be 2,000 grams of water. Well, 100 times what gets me up to 2,000? That's like 20 times, right? You do that by saying, well, 2,000 divided by 100 is 20. So whatever I get, I'm going to multiply by 20 because I have 20 times the water. So 50 degrees up to KNO3. Wow, these are off. You know what happened? The table G moved one time on me. But I think you're still getting the point. This guy should be pretty accurate. I think table G just moved on me a little. So 50 degrees up would actually still be right at the line that's coming across there. I see 85. That's going to be 85 times 20. 85 times 20 would be 1,700 grams would be able to dissolve. Just throwing out a huge number. Normally they don't do that. 25 grams is a quarter of the water. That is divide 100 by 4. So I'm going to find KNO3. I guess my 30 is going to be off. It's actually over a lot. Sorry about this, guys. It was a long video. I don't want to re-record it. I think you can find out that 30 is actually a slightly different number, it looks like to me. It should be more like 50 or 45 maybe, right? Divided by 4, 12 grams. So again, we change the amount of water. How much should I change the amount of water by? Make that change to the answer that you're finding on the chart, and we're off to the races. And with that, we should be donezo.